Okay, hi guys. We are going to cover the solutions in worksheet 6. There are some questions that I already covered. Some I will skip past because I think they are relatively easy. All right, so let's not hesitate. I'll just go into the solutions. Okay, question 1 MCQ, answer B. I don't think there's much to be said. Total energy is the same. This must be correct. And the kinetic energy at Q is greater than R because it's at the lowest point. So this is also correct. But this is wrong because the GPE at R should be lower than P because P is much higher. All right, total energy, if you ignore the effects of air resistance, total energy to be same at all 3 points. So D is the solution. This one is just a normal conservation of energy in terms of kinetic energy to GPE. So you just equate GPE equals to KE and then you can solve. You are given only the initial velocity, so you can then just do half mv square equals mgh. All right, you realize that m appears on both sides, so you can cancel. So this is a neat trick that sometimes they will test you in O levels, that the mass doesn't necessarily need to be given for you to be able to solve a conversion of GPE to KE kind of question. All right, G is 10 given here. The height is what you want to find. G, you know. Velocity is also given, so then it becomes solvable. So you can just check the solutions here. All right. 2 kg slides down. Calculate the total amount of energy lost to the surroundings. All right. Question also is relatively simple. You calculate the GPE you had at the start, which is just given by mgh. Then they tell you that the speed of the box at the bottom is 10 meter per second. So in theory, if there's no energy loss, all the GPE will have then be converted to KE here, which you can then calculate the KE here because you are given velocity here. All right, so which is what they did. Then they realized that actually the answer is not the same. So the difference in this is actually the energy that is converted to non-useful forms. In this case, thermal energy. All right, this one also quite simple. 80 kg man walk up a flight of stairs 4 meters to reach a height of 4 meters in 16 seconds. So you just need to calculate the work done by the man in the first place. All right, so the work done by the man is the minimum he needs to apply to be able to move upwards. It must be equivalent to 800 newtons because his weight is his mass is 80 kg, which means his weight downwards is 800 newton. So the very minimum he needs to apply a 800 newton force. So he needs to do at least 800 newtons over a distance of 4 meters. And then you calculate that, you get this amount. This is the work done, and he does this amount of work in 16 seconds. So just divide by 16 to get the power. All right, this question also can be kind of tricky. The work done by the force, the box travels 10 meters. So the work done by the force is actually 8 times 10, which is 80 joules. Now, frictional force accounts for 6 newtons out of the 8. So 6 times 10, this is the amount of energy. So actually, out of the 8 newtons that he's applying here, 6 of them is used just to counteract the frictional force. So the amount of work that he needs to do to overcome friction is 6 newton times 10, which is 60 joules. Which means then the balance of 2 newtons, 2 times 10, the 2 newtons, it will go into the kinetic energy. So the KE will end up being 20, the thermal energy is 60. All right, I believe we have done question 1 in class. Question 2 also we have done in class. But in case you missed it, you can just check the answer on Google Classroom. Question 3 also done in class. All right, so just to check the answers for here. And question 4, an object of mass 1 kg falls through a height of 5 meters before hitting the ground. Calculate the initial GPE, quite trivial, just mgh. Mass times g times 5, which is the height, you get 250 joules. So assuming that air resistance is negligible, so there's no transfer to thermal energy, which means state the gain in the KE. That means all the GPE must have then be converted to KE. So there is no need actually to calculate. Whatever you calculated for GPE is equals to 50 joules because all the GPE is converted to KE. So how do you derive? You just explain using principle of conservation of energy. So what are the important things that you need to say for you to get the mark? By principle of conservation of energy, you state the whole statement about principle of conservation of energy. Energy can neither be created or destroyed, but only converted from one form to another. Then you say, because air resistance is negligible, given in the question here, so there is all the loss in the GPE goes to the gain in the KE. Right, so that will net you the 2 marks. So 1 mark from here to here, another mark from here to here. All right, so find the maximum speed. Again, we use the same trick that we do. GPE gain, all right, the GPE loss is equals to the KE gain. Again, MGH equals to half MV square. You notice that in the question, they didn't give you mass, but doesn't matter because the mass cancels out. G is 10, height is given as 5 meters. Is it right? Yep, 5 meters here. So 10 times 5 is equals to half V square. All right, then you can just solve it. Find V by just doing solve for V and you get the answer. All right, moving on to question number 5. You got a man who's a student walking of mass 50 kg walking upstairs. They ask you to calculate the power if the work done is 1,200. So just power equals to work done over time. Time is 10 seconds. Calculate again in GPE again because it's 50. It's quite trivial lah. MGH GPE equals to MGH. Mass is given here. Height is given here. G is supposed to be equals to 10. G is here 10, right? MGH. So in this case, if you look at it, the work done by the fella is 1,200 joules, but in the end, he only gains 1,000 joules. So suggest why the gain in GP is different is because some of it is always lost. So whenever they ask you things like why is it that the gain in energy is not equivalent to work done, then because you say that some of it is converted to thermal energy due to friction. All right, we have done this question before, but also quite similar. All right. Wooden box of mass 10 kg is subjected to, okay, right? So constant speed. So you know that KE is constant. All right. Horizontal distance of 3 meters. Frictional force is given by 15 newtons. Calculate the work done. All right. So because he's traveling at constant speed, you know for a fact that the resultant force is 0 newtons, which means if the box is moving and it experiences 50 newtons of frictional force, that means the driving force must also be 50 newtons for it to result in a resultant force 0. So that's why they make the assumption here the applied force is equivalent to 50 newtons. So work done is just force times distance. It travels a distance of 3 meters. Then just force times distance 50 times 3. All right, a box is carried. Okay, this one also quite easy. You just the work done is equals to mgh. Why can I say this? The box again is 10 kilograms. So two ways that you can think of it. So if the mass of the object of the box is 10 kg, it means that the weight is 100 newtons. Because W equals to mg, 10 times 10 is 100. So at the very minimum, whoever is doing work needs to apply at least 100 newtons for it to be moving upwards. So then you can calculate either the work done as just force times distance. It needs to apply 100 newtons over a distance of, oh, it's an annoying question because it's 3 meters between two levels. You start off at level 1, level 2, level 3, 4, 5, 6, 7, 8, 9, 10. So if you calculate, there's actually 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So each of them is 3 meters. So that's why they did 9 times 3 is 27 meters. So then you just multiply by 27 and you get 2,700 joules. Now, another way, this is first way. The second way you can think about how to calculate is because they never mention about any gain in KE or whatever. So you assume that all the work done goes into increasing the GPE or goes directly into the GPE. So the work done oftentimes can also just be directly calculated as equivalent to GPE, which is what they did over here lah. Work done equals to MGH here. So just 10 times 10 times the distance 27, you also get 2,700 joules. All right. this question is slightly difficult. All right, so let's look at it. A dam situated 600 meters above provides a rate of water flow of this amount, kilogram per second. That means this amount, this is 4,000 kilograms of water is moving past it every second. So they ask you to calculate the amount of electrical energy. So to calculate the work done, to calculate the power is actually the work done over time. Now the work done in this situation, they never mention anything else because the dam is situated 600 meters above ground. So you know that's GPE. All right. So the work done actually is equivalent to the GPE of equivalent to 600 meters above ground and this amount of water. So the work done is just mgh, which is the GPE of the water over time. Now, this question is a little bit difficult because you need to identify that this is actually the amount of mass passing by in 1 second, mass per unit time. So if I separate it out, then I get m over t gh. And then this is equivalent to 4 times 10 to the power 3, which is the amount of mass passing by per second, times 10 times the height, which is 600, which is what they did here. All right, and then you get the answer as 2.4 times 10 to the power 7 watts. All right, which they then converted to megawatts, but not necessarily at the O level. You can just leave your answer in standard form like that. So if it's 90% efficient, then you just basically take this value times 90% lah. Right, not so difficult lah. So 2.4 times 10 to the power 7 times 90%, which is actually 90 over 100 lah, and you will get this answer. All right, I believe we did this in class. All right, this question also is not that difficult. Just try and use the same reasoning we did for the dam. All right, they have this flow rate thing, which is the mass per unit time. All right, try and figure out the solution for yourself. All right.